All right, welcome back to the Deep Dive, the place where we process massive stacks of information docs, articles, research, and distill it all down into the knowledge you can actually use.
And today, we are diving into something that is, I think, one of the most powerful concepts in Python for just immediately leveling up. We're talking about the standard library.
Right. It's not just a toolkit, it's more like a pre-solved problem set.
Exactly.
So our mission for this deep dive is really focused. We want to know how you can gain huge amounts of functionality fast. We're looking at Python's standard libraries or modules to figure out not just what they are, but how to really use them.
Mm-hmm.
The goal here is to turn those coding headaches, the things you'd normally spend hours building from scratch,
Right.
into problems that are already solved for you.
And that's solved brilliantly. This is the ultimate built-in toolkit. I think the key thing for anyone learning is that this knowledge is just instantly available. Zero configuration, zero downloads.
It's just baked right in.
It's baked right into Python, yeah, giving you immediate access to expertise in math, system control, even security.
Okay, so let's just unpack this a little. When we say standard library, what does that actually mean? Is it just a folder of files or?
In a way, yeah. It's a huge collection of what are called modules, and they ship with Python itself. A module really is just a single file of Python code.
Okay.
So when you start a script, you're in a clean environment. The modules hold all this specialized knowledge, and you turn on that knowledge by importing them.
And when we import a module, what are we actually bringing into our workspace?
You're bringing in predefined names, and these names, they basically represent two things: functions and data, or constants.
Okay, so functions are the doing words, the tools.
Exactly. They're the recipes for doing something complex, like calculating a logarithm or hashing a password securely.
And what about the constants? Why are those so important?
Well, a constant is a piece of verified specialized data. Let's take the math library again. You import math, you immediately get math.pi.
We're not number pi.
But why is that valuable? Because trying to type out pi to, say, 20 decimal places is tedious, and you're probably going to make a mistake.
Oh, for sure.
The standard library gives you that knowledge perfectly verified by the community. So you can focus on your problem, not on data entry. It just adds immediate reliability.
That's a great point. It's not just about speed. It's about a level of quality control that's already been done for you. And the scale of this whole thing is just enormous.
It is.
The sources we looked at, they point to this comprehensive index of all the Python standard libraries. Just looking at that list is kind of mind-blowing.
Absolutely. That link to the documentation index, that's your map. It shows you this isn't just a handful of utilities, it's hundreds of specialized tool sets just waiting there.
So if the task is common, Python has probably solved it.
That's the fundamental idea. You just need to know the right name to import.
Which brings us to the operational know-how. If these libraries hold the knowledge, how do we physically, tap into it in our code? Because I assume there's a right way and a wrong way.
Oh, absolutely. And this is where we get into what separates, let's say, amateur code from professional code. We have to look at the PEP8 guidelines.
The official style guide for Python.
That's the one. And for imports, PEP8 is all about clarity and organization.
So what's the golden rule here? What's the cleanest, most professional way to do it?
The primary rule, the one you should almost never break, is each imported module must be on its own line.
Okay. So you write import Oz on one line and then import time on the next.
Exactly. You should never, ever string them together with commas, like import Oz, time, even though Python technically allows it.
And why is that so important?
Readability and maintenance. If a module is causing a problem, you know exactly which line to comment out. It makes auditing your code's dependencies trivial.
That makes a lot of sense for debugging. But what about efficiency? Say I only need one function, like Squirt from the giant mass library. Do I have to import the whole thing?
That is a fantastic, practical question, and it gets to the heart of it. You're right. Importing the whole thing can feel a bit heavy. This leads to the one acceptable variation.
Yeah.
If you only need a few specific names, you can use the syntax from module name, import name1, name2.
So you can pull Squirt out directly and then just call it as Squirt instead of math.sqrt.
Precisely. And that's a perfectly fine thing to do. But here's the nuance from PEP8 that really separates great code from good code. It's about how you group those imports.
Grouping, you mean the order.
The order and the separation. PEPA says your imports should be in 3 distinct blocks with a blank line between each block.
Okay, what are the blocks?
First, you list all your standard library imports, so OS, math, all the stuff we're talking about today.
Got it.
Second, in the next block come the third-party library imports, things you installed with pip like pandas or NumPy.
Right, the external stuff.
And finally, the third group is for your local application imports, the other files that you wrote as part of your project.
Wow. Okay, why is that grouping so fundamental?
It creates an instant dependency map. When something breaks, a developer can look at the top of the file and know immediately, is this a core Python thing? Is it an external library we need to check? Or is it our own code?
It's like a manifest for your script.
It's a manifest. That is the perfect word for it. It turns imports from just a list of things into a structured part of your software's architecture.
That really adds a lot of depth. So now that we know how to bring the knowledge in properly, here's where it gets really interesting. Let's look at some of the libraries that give you that instant power.
Absolutely. And we have to start with the true intellectual workhorse. We need to talk about the math library.
We've mentioned it a few times. It's got Pi.
It's got Pi, but its real strength is in the optimized, highly specialized mathematical functions. Anything for engineering, science, finance. It's in there.
Give me a concrete example. What's a function we would never want to write ourselves?
Okay. Think about math.tan to yx.
The arctangent.
It's more than that. This function is crucial for things like mapping or robotics because it calculates an angle, but it correctly handles which of the 4 quadrants the angle is in based on the signs of x and y.
Ah, right. That's a detail that's really easy to mess up.
Incredibly easy to mess up if you try to code it from scratch with a bunch of if statements. The math library guarantees that the complex logic is precise and correct every single time.
That's a perfect example of pre-verified knowledge. It frees you up to think about the bigger picture. But, okay, if a learner imports math, how do they find out what's actually in there?
This is, hands down, the most practical, empowering tip we can give. For any standard library module, you can run the command help module name.
Wait, you mean the documentation isn't just online, it's an active part of the language?
It is. You type help, math, right in your Python interpreter, and boom. It prints out all the functions, what they do, what they expect, right there in your session.
That's incredible.
It turns documentation from a passive website you have to search for into an active, searchable command.
So you can explore any module we mention or any you find on that big list instantly.
Instantly.
That's a game changer. Okay, so beyond pure math, what about controlling the environment? Where does the library let us interact with the real world?
Well, once you move beyond the abstract, you get into utility and system control. And for that, the OS module is just indispensable.
Operating system.
Yes. And it's so important because it lets your code talk to the machine it's running on. And the problem it solves instantly is file paths.
Oh, the classic slash versus backslash problem.
Exactly. Windows, Mac, Linux, they all use different separators. If you hard code a path with the wrong one, your script breaks as soon as it's run on a different machine.
I've definitely made that mistake
Or
before.
we all have. But the OS library knows how to handle it. You use os.path.join, and it automatically uses the correct separator for whatever machine is running the code. Your script becomes instantly portable.
That one function saves so much headache. It's one of those aha moments when you discover it.
It's a perfect illustration of why the standard library exists. And the utility keeps going. You've got time for all your, time access and conversion needs.
Like timing how long a function takes to run.
Yep, or formatting a timestamp for a log file. It handles all of that.
And what about when you need things to be unpredictable? For simulations or tests?
That's where the random library comes in. It generates pseudo-random numbers, which are critical for everything from shuffling a list to running statistical models. It's a robust, well-tested way to inject randomness.
Got it. And next up, the one that lets our code talk to Python interpreter itself.
That would be sys. It stands for System-Specific Functions. This is how you interact with the environment Python is actually running in. For example, if you need to read command line arguments that were passed to your script,
Did you use sys?
you look at sys.rgv, exactly. It gives you control over the session itself.
And finally, something everyone who deals with data needs. Text manipulation.
Handled beautifully by the string library. Now, Python's built-in string methods are already great, but the string module gives you useful constants,
Like what?
like string.punctuation or string.ASCII. If you need a guaranteed complete list of all punctuation marks, you just import it. You don't have to type them all out yourself. It's just reliable knowledge ready to go.
So just with those 6 math, ULS, time, random, sys, and string. We've covered scientific accuracy, system control, time, randomness, interpreter control, and text manipulation.
It's a huge productivity boost, and we've barely scratched the surface. These are just the verified, optimized solutions waiting for you.
So let's bring this deep dive home. The core lesson here seems pretty clear. Standard libraries are these pre-built modules, just packed with functions and constants.
Pre-verified knowledge.
Exactly. They give you access to all this specialized information, from complex math to file systems, and all you have to do is follow those clear, professional import rules.
Especially the PP8 grouping. That's the real pro move.
You skip the headache of building the tool and go straight to using it. It's a gateway to faster, more robust code.
And this really brings up an important question for you, for the learner. Given that you can see that complete index of all Python standard libraries, that huge list of hundreds of modules, just think about how much specialized knowledge you could gain by learning the name and purpose of just one new module a week. What specific niche problem do you think Python has already solved for you that's just waiting for you on that list? Something beyond the common tools we talked about today.
That's a great thought. What's already out there, just waiting to be imported. Until next time, keep diving deep.